What's up, you guys? In this video, I'm going to show you how to automatically split a video clip into its separate parts. So this is especially great for a compilation clip. Let's say you found a few compilation clips and you want to split them all into their own individual clips so that you can compilate the clips. So let's say this one, for example, we can play it. It has there just changed, right? So and then
Bro,
it's gonna
there's
change
no
soon.
way. Yay!
So it just changed there again. So that's what I'm talking about. You can split a clip like this compilation clip into its own clips. So let's say you found 10 dog videos that were all compilations. You could split it into 100 of its own clips and then automatically recompilate them into different videos. So that's sort of the use case that I had in mind. And I figured out how to do it just now. So um, it starts with replicate, which is a way that you can run models in the cloud, and it has a lot of different models that you can try out very easily using their API. So the first thing you need to do is use the video to frames model here, or you can also do it a lot of different ways. And the downside to this model is that it has you can only do 1 frame per second, so it's not going to get it 100%. You'd more rather have one that can do maybe 10 frames per second, but it might be a bit costly. So uh, I've just done 1 frame per second in this example, and this will change your video into frames. So here I already posted this dog video into the replicate Dropbox, and this is just the playground. And I pressed run and I got all the frames of the video. So in the JSON output, you can see every frame here in a PNG file in the output key, and so they also post them to the cloud, which is easy for just trying this out. So basically what you need to do is run the video to frames, or get the frames different way in Python, which is not hard, I don't think. And you may not even have to use an AI model. But yeah, in this example, just copy the JSON output here, and I copied it and I put it in images.json. And so you can see in the output there's all these PNGs, and then the first bit of code here is there's not a lot of code. It's just open the JSON file and put it into a variable, then do a for loop with a range of 50, and then what we need to do is run the image bind model here. So the image bind model will make a matrix or an embedding with like 100 or more different dimensions, and that'll give you a really good like numeric representation of what's in the photo. So what I did here is you can run it using this piece of code on the replicate page. So I did a for loop to get every PNG up to 50 seconds and 50 PNGs, right? And then you run the image bind model to get the embedding for each image, and then put that in a JSON file. So the py output.json looks something like this. I don't know if I can format here any better, but yeah, as you can see, like 0 is there, 1 is there, and each key in this dict has the embedding for the photograph. So after you get the embedding, all you need to do is like an easy little bit of code to get the cosine similarity. So we're using sklearn cosine similarity. And what I did here in this similarity.py file is I got the output of each embedding for each frame in the video, and then I did a for loop just in the range 40 just to try it out. So that's going to be up to 40 seconds and 40 PNGs. And then here is the actual embedding that we're going to use. You just make a numpy array, so write numpy as np, numpy array of each embedding. So how it looks with 4 dimensions here, it's very easy to make this cosine similarity. You make a numpy array, and now I'm on Google Chrome, numpy array of the embedding, and then you take the second embedding and you make a numpy array of that as well. So we're comparing the 2 different frames. So after you do reshape, I think that just reshapes it to like less dimensions or something. Maybe, I'm not 100% sure of that. And then you get the cosine similarity between the embeddings. And then I'm just printing the similarity here. So this is an example of the output down here in the terminal. 0.95 is the first, 0.82 is the second, 0.92 is the third, and 0.65 is the fourth. And if you're talking about the which frames this is comparing, the first one is comparing the first and second frame. The second one is comparing the second and third frame. The third number is comparing the third and fourth frame. And then the fourth number is comparing the fourth and fifth frame. So as you can see, there's a pattern here where we got 0.95, then we got I'll make this a bit bigger, 0.95, 0.82, 0.92, and then it drops to 0.62. And then we have 0.9, 0.8, 0.87, 0.88, 0.9, 0.87, and then 0.6. So these are the outliers. Is there's some 0.6s in there, but most of the time it's above 0.8. So what I did is, if the similarity is less than 0.8, that's an outlier, and that means that the difference between the 2 frames is quite big. So that's an indication that there's a clip change, right? So if the similarity is less than 0.8, I put it in a dict, and then I wrote the output to a JSON file, and this is what the JSON file looks like. And I'm just taking the frame that it changed on. So it changed on 5, it changed on 12, changed on 18, changed on 27 or 25, and then 29 is 0.77. So maybe that's something, maybe that's not a frame change because it's on the fence. So you can maybe change the similarity to be less than 0.7 if you want it to be safe. But then we have 31, which is 0.4, 38, which is 0.56, and 40, which is 0.5. So if we go back to the frames that we got at the beginning, counting them here, so 1, 2, 3, 4, 5, and then on 5 it's a clip change. So that one was correct. Because we got number 5 is 0.62, and that's correct. So then counting again, 6, 7, 8, 9, 10, 11, 12. Wait, no, okay, I miscounted that. because I've already looked at this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, it's a clip change again, and so it looks like we got that one corrected as well. So you can go through the rest of them and see if they got them correct. But this is 0.47. I'm guessing that's correct. So 12. So yeah. 12, 13, 14, 15, 16, 17, 18. Yeah, that's a clip change there. And we got that one correct as well. So this is just like an easy way to like automatically split the clips. Ideally, like I said, you would want to do more frames per second and split the clip into maybe 10 frames per second or even more, but I think most videos are 24 to 60 frames per second. But if you're going to be doing 24 to 60 frames per second, splitting that and then doing the cosine and then doing the image bind model for each of those frames, I imagine it's going to be pretty expensive and it might take long to run. But if you have a GPU and you can run the models locally, that'll save you a lot of money. But yeah, so other than, doing more frames per second so that you can cut them at the exact right spot, that's just like, this is just sort of like a little test model of how you can automatically split compilation clips specifically into their own clips and then recreate them. Obviously that's a little bit of other code, but that's easy using MoviePy. So yeah, if you found this video helpful, please like and subscribe, and I'll see you in the next video.